Good morning. Today we will discuss diffraction due to double slit. Okay. In last class we have learned diffraction due to single slit. Here we are considering two slits of width B. Okay. Then parallel rays of light or plane wavefront is assumed to be incident on this slit. Okay. Plane wavefront is normally incident on this slits. That is, slit width is B. Each slit has width of B. Then the D is the distance between the two slits. Actually, that distance means the corresponding points from each slit. Actually, here if you consider this point from this to this point. Okay. Then if you take the center point of this, then center to center, center point of this slit will be the D. Distance will be D unit. Okay. Then B unit will be the slit width. Okay. Now what will be our diffraction pattern which is placed diffraction pattern on the screen, which is placed at an infinite distance from this slit. Actually, instead of placing infinite distance, then what we are doing is we are keeping one convex lens for collecting this image then at the focal plane. That is, actually the screen is placed at the focal plane of this convex lens. So you can have diffraction pattern at the focal plane of this convex lens. Okay. Last class we found the same pattern. It's a normal incidence and plane wavefront, and that's why I showed here as a parallel rays. Then slit width is B. Then the corresponding distance between each slit. അതായത് ഓരോ സ്ലിറ്റിലെ corresponding points തമ്മിലുള്ള distance എന്ന് പറയുന്നത് D ആണ്. Corresponding points means here if you consider this point, you have to consider this. Then this point you have to consider this. Okay, center to center like this. If you consider this point, you have to consider this. That's why the distance is taken as a D. Okay. Then usually we expect rectilinear propagation, expect the illumination in this region and in this region only. Okay, but instead of that we are getting an interference pattern which looks like this actually. See, in last class we got interference pattern like this. Pattern like this, that is diffraction pattern like this, that is diffraction due to single slit. Instead of that we are getting, see what is, instead of that actually it will be like this. You are getting like, means in each diffraction pattern you are getting many maximas and minima. Okay, inside diffraction pattern we are having some what alternate dark and bright fringes. So many dark and bright fringes is included or is confined within the diffraction pattern. Okay, അങ്ങനെയുള്ള ഒരു pattern ആണ്. This it looks like actually like this. Actually, if you take the profile of this, it will be like our diffraction pattern, right? Diffraction pattern. Actually, profile diffraction pattern. If there is no double slit, you can have the pattern like this. But if we use two slits instead of one slit, the pattern will be changed into like this. Means inside this diffraction pattern you cannot see the diffraction pattern. Actually, you will see the dark and bright fringes. So many dark and bright fringes is across these slits. Okay, so why this type of intensity or intensity distribution comes. That we are going to discuss here. Okay. So actually what is happening here? See, here is if we are, see, suppose we are using only one slit, okay, you can have diffraction pattern at P, okay, due to this slit. Why slit diffraction pattern P? Suppose I block here and I use this this slit, then also you can have some diffraction pattern at P due to this slit. Okay, but this individually this slit also produces diffraction pattern. This slit is also producing diffraction pattern. Then what will be the combined effect? The combined effect will be the superposition of these two effects. That's all. Okay. So here we know in this case we know what is the electric field or what is the disturbance emitting from these slits, and what is the disturbance emitting from this slit, and that we know, and in this case also we know what is the disturbance or electric field coming from this slit. That we already done in last class. I don't know you remember it now. Let E1 be the electric field or disturbance reaching at point P from this slit. Okay, that will be, you remember, A sine beta by beta, right, cos omega t minus beta. I think you remember. So, last class is diffraction due to single slit electric field net. Yeah, actually what is happening, each point source emits on disturbance or electric field. Then we in last class we have added all this electric field, and we got some expression. That's what I1 is equal to A sin beta by beta cos omega t minus beta. Similarly, beta by beta is equal to, that you remember, beta is equal to pi b sin beta by lambda. Okay, beta is equal to pi by lambda b sin beta. Theta is the diffraction angle. Here it is diffracted through an angle theta, right? Okay. So, the electric field due to this slit, first slit. Then this slit also emitting the same electric field. But what is the difference between this electric field and this electric field? Okay, then what is the difference? There is some phase difference. Okay, so one of the electric field is emitting from here, then other is emitting from here, then there will be some phase difference between these two electric fields. That's all. Okay. Actually, what you have to do is, the last electric field at the add. Within this, there will be some constant phase difference between each point source. Okay, and same, but that we have already done in last class. We are taking directly actually we are quoting that expression here. Okay, expression directly diffraction pattern, slit diffraction pattern, electric field. So, this electric field individually same thing. But here what we have to do, at point P, these two electric fields shows some phase difference, or there will be some optical path difference. Okay, if you take corresponding point between this point and this, then if you draw the perpendicular, then d sin theta will be the optical path difference. For each corresponding points there will be optical path difference d sin theta. So the phi, what will be the phase difference between this electric field and second electric field? There will be phase difference phi, which is what? 2 pi by lambda d sin theta. See, here if you draw a perpendicular to this point, this will be theta, then d sin theta will be the optical path difference between this this ray and this ray. Then optical path difference, this ray will take. So in effect, the electric field, we have the combined electric fields from this link and this link. Then if you take in now, what you have to do is at point P, this E1 and E2, the electric field from the E2, the both will interfere. There will be superposition of these two electric field. Okay, then that will be deferred by some phase. That is our 2 pi by lambda sin theta. 2 pi by lambda d sin theta. Phi is equal to what? Phi is equal to 2 pi by lambda d sin theta. Okay, I think you understood. Now I can write E2 is equal to what? A sin beta by beta. A was, I don't remember, we have taken A as the amplitude in last class. If it is E0, you give E0. That is in that. Sin beta by beta cos omega t minus beta minus phi. Right? There will be some phase difference between these two. Okay? That's all. Now we have to find out what is the net resultant electric field at point P. Then you should square, or you should take the complex square, E square, for getting intensity distribution. So E square means I am what E is star actually. Complex, you have to take complex conjugate of electric field for squaring this. Okay, now anyway, the net electric field is what? E is equal to E1 plus E2. Okay, right? Then you can have what? If you add these two, then sin beta by beta cos omega t minus beta plus cos omega t minus beta minus 5. Okay, it is like cos c plus cos d. Okay, then the resultant will be 2 cos c plus d by 2 and c minus d by 2. Say c plus d means what? Omega t minus beta plus omega t minus beta. You will get 2 omega t minus 2 beta minus 5. Okay, by 2. By 2 will be, so we will do that one. That is E is equal to A sin beta by beta 2 cos omega t 2 omega t minus 2 beta minus 5 by 2. Okay, so by 2 is here, so I am cancelling these 2 and I am giving 5 by 2. Okay, omega t minus beta minus 5 by 2 cos c plus d by 2 and cos c minus d. C omega t minus beta minus omega t plus beta plus 5. So omega t minus omega t will be cancelled, minus beta and plus beta will be cancelled. So you have got cos 5 by 2 only. Okay. So the final result will be like this. That is our electric field. Then for calculating intensity, I is equal to E is star, but we are not taking as a complex quantity here. So it is E square, that you can directly square this. So you will get intensity 2 for A square sin square beta by beta square what? Cos square 5 by 2, then cos omega t minus beta minus 5 by 2. Okay, the final result. Where 5 by 2 is what? 5 by 2. Let 5 by 2 is equal to, let 5 by 2 is equal to gamma is equal to, it is actually 2 pi pi by lambda d sin theta. So it is pi by 5 is actually 2 pi by lambda d sin theta. Pi by 2, 5 by 2 means pi by lambda d sin theta. Okay, you have to remember beta is equal to pi by lambda d sin theta. That is actually path difference, phase difference between these two. Within this slit, each slit, then 5 by 2 is equal to pi by lambda d sin theta. That shows the phase difference between the slits. Okay, between the separate slits. Okay, pi by lambda d sin theta. So if I take this cos 5 by 2 as a gamma, then our expression will be cos square gamma cos. Then if I write a square, we have last class we had written like I0 means for I0, that is intensity of the central maxima, you remember, right? Then for I0 sin square beta by beta square. Actually you have to square this also, but for intensity we have modulation, or for showing intensity distribution, you have to take what this, you have to take this amplitude square, then intensity will be, okay, intensity will be for I0 sin square beta by beta square cos square gamma. This part actually shows the nature of what electric field. Okay, that wave nature omega t minus beta minus 5 by 2. Actually, this part actually shows the electric field wave, but actually this part is the amplitude of this resultant electric field. Okay, this amplitude square will give you the intensity distribution. Okay, intensity distribution pattern actually. So actually this factor modifies this our intensity. So here by looking this expression, see this part you have done. Okay, without the last class the expression looks like this: diffraction due to single slit. Then this expression, what, without sin square beta by beta square, that is for I0 cos square gamma. That also you know. Okay, you remember, I think in interference you have studied this expression. For double slit experiment, especially double slit experiment, you have done calculated I is equal to I0 for I0 cos square delta by 2, right? Cos square delta by 2. Here it is gamma. That's all. So this term here shows the presence of interference from the each slit, from the double slit. Okay, each slit nulla interference na kanikkunna term for I0 cos square gamma. Same time this term shows the diffraction from each slit. Okay, so appo nammade ee diffraction due to double slit ennu parayunnathu namukku parayam, there will be diffraction from each slit and there will be interference from the double slit. Okay, ee double slit nalla interference adeypole thanne oro slit nalla diffraction pattern combined effect, combined phenomenon. Actually combined effect will be shown like this. Actually this interference pattern, diffraction pattern. So if you draw, draw the graph with what beta or theta with the intensity, you will get the graph looks like this, or intensity distribution will be like this. You can have, actually you know this, if there is no diffraction, you have for I0 cos square gamma. Gamma is a function of theta. Okay, then if you draw this graph, you have what? Uniform intensity maximas and minimas that you have done in reference, right? But instead of because of this diffraction effect, this intensity pattern actually looks like this. by it's a slowly varying function. This differential pattern is slowly varying function. But interference is a fastly moving function. Okay. Now, due to the effect of sine square beta by beta square, the intensity pattern will look like this. You have secondary maxima and minima. Within that, you can have this type. So, each cell, this is our central maxima of the diffraction pattern. Within the central maxima, you have many dark and bright fringes. That I have shown here. You actually this will correspond to central maxima, but you will see the diffraction pattern like this. Okay, diffraction pattern. There are many in about maximas and minimas which is decayed over when we increase the theta. Okay, why there is such intensity pattern? So now, double slit experimental, we have considered this as a point source. Beta B is negligible. Beta or the width of the slit actually we are not considering in the Young's double slit experiment. If we neglect the width, see beta is equal to B means when B tending to 0. When B tending to 0, beta will tend to 0. Then when the beta tends to 0, we know we have sin beta by beta is equal to what? 1. So you have the expression for I0 cos square gamma. That will give you the expression for what? Expression for the double slit interference. Young's double slit interference. So here what we are doing is instead of you neglecting this B, then we are giving some finite width for this slit. Okay, a slit is finite width. So that will make this slit what? There are finite point sources for in each slit. Okay, there are so many point sources that will again emit secondary wavefronts that will interfere at here. Similarly here also. So the combined effect will be there is a diffraction phenomena and what there is an interference phenomena. So the combined effect is this interference from the double slit interference. So electric field interfere effect. Each slit diffraction combined combined that will be look like this. The interference, you can see in general beta in the order beta is equal to B means what? We know first interference diffraction max minima. See, diffraction pattern, we simplicity theta. Theta is the first diffraction minimum angular divergence, diffracted angle. Or actually, it is the spreading of light. Okay, spreading of light in the central maxima will be within the angular width of 2 theta. Okay, 2 theta like is theta also. Theta we know for theta is equal to it is lambda by b. You remember the equation b sin theta is equal to m lambda is the condition for the minima. So first minima will be within the range. Theta is equal to plus or minus lambda by b iq plus lambda by b d. Theta is equal to lambda by b and lambda by b. Within the 2 lambda by b width the angular width spread ഉണ്ടായിരിക്കും. Same time here interference in the minimum diffraction sorry the diffraction diffraction minimum same interference in the minimum equation actually it will be our interference maximum in equation. The maximum കാണുന്ന theta എന്ന് പറയുന്നത് in the order of number we will derive it, or you have d sin theta is equal to d sin theta is equal to m lambda, or m lambda will give you the condition for maximum. So the theta corresponds to, that is angular difference, angular divergence. Our divergence correspond to the interference maximum. First interference maximum, it will be like lambda by d. But d in general, b is very small compared to d. d ആയി നമ്മൾ അങ്ങനെയാണ് എടുക്കുന്നത്. അല്ലാത്ത കേസ് നമുക്ക് ഇങ്ങനെ പറയാൻ പറ്റില്ല. പക്ഷേ slit width is very it is comparable with the wavelength. Then only the diffraction will be observable or noticeable. Okay. But d, there won't be any restriction here. So d is the distance between these two slits. Okay. So then generally d is very greater than b. So in such case theta is very small compared to this theta. Okay. Then the interference maxima will be within this. Then next theta or the next maxima ഇതിന്റെ ഉള്ളിൽ തന്നെയായിരിക്കും. So അതുകൊണ്ടാണ് for ഈ diffraction pattern ന്റെ ഉള്ളിൽ തന്നെ കുറേ എന്തുണ്ടാവും, there will be many interference maximas. Maximas ഉണ്ടെങ്കിൽ there will be interference എന്താണ് minimum. Okay. അതെന്തുകൊണ്ടെന്ന് വെച്ചാൽ ഇന്റർഫറൻസിന്റെ മാക്സിമസിന്റെ angular divergence എന്ന് പറയുന്നത് lambda by d ആണ്. d എന്ന് പറയുന്നത് വളരെ സ്മോൾ ആയിരിക്കും lambda by b ആയിട്ട് കമ്പയർ ചെയ്യുമ്പോൾ. വളരെ സ്മോൾ ആയതുകൊണ്ട് കുറേ നമുക്ക് മാക്സിമസിന് അതിൽ എന്ത് ചെയ്യാൻ പറ്റും, നമുക്ക് അതിൽ ഉൾക്കൊള്ളിക്കാൻ പറ്റും. അത് നമ്മൾ കണ്ടീഷൻ നമ്മളിപ്പോൾ ഡിറൈവ് ചെയ്യാം. എനിവേ, സോ അതുകൊണ്ടാണ് ഇന്റർഫറൻസ് പാറ്റേണിന്റെ ഇന്റർഫറൻസിന്റെ ആക്ച്വലി മാക്സിമ മിനിമയാണ്. പക്ഷെ ദാറ്റ് വിൽ ബി ഇഫ് ദർ ഇസ് നോ ഡിഫ്രാക്ഷൻ, all interference maximas and minima will be what within will have uniform intensity. But due to this modulation effect of this diffraction, then the net intensity distribution will look like this. Okay, that's what. So that's why. Now we have to find out what are the positions of maxima and minima. This pattern was maxima, minima, the positions. Okay. Now we have this expression. We have this expression that is I is equal to what? 4I0. You remember 4 comes for in the case of in the case of 2x double slit there will be 4 factor 4. Okay. 4I0 cos square gamma. Oops. Sin square beta by beta square cos square gamma. Now the positions of minima. Okay. Now the position. You know I is equal to 0. At position I is equal to 0. That is minimum. Simple. Minimum in the case beta is equal to m by I. Okay. But m not equal to 0. Because m not equal to 0 case this is a condition for central maxima. M not equal to 0, but m is equal to 1, 2, 3. Okay, m is equal to 1, 2, 3, etc. Sin m pi it's always 0. Otherwise, any factor mottam 0. Otherwise, what? Gamma is equal to n plus half pi. Right? Correct. Gamma cos pi by 2 and then 0 on. Cos 90 is 0 on. Then 3 pi by 2, 3 pi by 2, so 5 pi by 2, etc. Here n starts from what? 0, 1, 2, 3, etc. Okay, remember 1, 2, 3 and 0, 1, 2. Okay, in another case, and then this our interference and the intensity will be, and then intensity will be 0. This is actually the diffraction pattern intensity 0 on the case. In case, our intensity pattern intensity 0. Same time, this equation interference pattern intensity 0. Now, this graph the interference minimum. ഇവിടെ ഇന്റർഫറൻസ് മിനിമം, ഇവിടെ ഇന്റർഫറൻസ് മിനിമം. അപ്പോൾ ഇവിടെ എന്താണ് ആക്ച്വലി ഇന്റൻസിറ്റി എന്താണ്? 0 ആണ്. ഈ പോയിന്റിൽ ഇന്റൻസിറ്റി 0 ആണ്. ഈ പോയിന്റിൽ ഇന്റൻസിറ്റി 0. അപ്പോൾ അങ്ങനെയുള്ള പോയിന്റ്സ് ആണ് ആക്ച്വലി എന്ത് ഗാമ is equal to n plus half pi എന്ന് പറയുന്നത്. Okay. Now this actually beta is equal to pi by lambda b sin theta. So if you give pi by lambda b sin theta, then you will have this expression as b sin theta is equal to what? B sin theta is equal to m lambda. M is equal to 1, 2, 3. Okay. M is equal to 1, 2, 3 ൽ diffraction minimum ആണെങ്കിലും നമ്മുടെ ഇന്റൻസിറ്റി റിസൾട്ടന്റ് ഇന്റൻസിറ്റി എടുത്തു കഴിഞ്ഞാൽ ആ പോയിന്റിൽ 0 ആയിരിക്കും. അതേപോലെ തന്നെയാണ് ഗാമയുടെ you give gamma is equal to pi by lambda d sin theta. If you give this, then you have d sin theta is equal to, right, see, then theta is equal to n plus half lambda. Okay. So this b sin theta is equal to m lambda and d sin theta is equal to n plus half lambda. This is for interference, this is for diffraction. Okay. D sin theta, d you give just for differentiating this, that's all. B sin theta is equal to m lambda, then b sin theta is equal to n plus half lambda. Theta is the diffracted angle or angular divergence of that particular point. Okay. Now this is for the condition for minimum. Minimum നമുക്ക് ഒരു കുഴപ്പമില്ല. മിനിമം എന്ന് പറയുന്നത് ഈ രണ്ട് കണ്ടീഷനിൽ ഏതെങ്കിലും ഒന്ന് സാറ്റിസ്ഫൈ ചെയ്താൽ മതി. The combined effect will be max. What's there? Then the condition for diffraction maxima, we have discussed, but here we have to discuss condition for interference maxima. Okay. Now for maximum interference maxima, the condition will be what? Gamma will be 0, okay, 2 pi, etc. So you have to find out the interference maxima. That means gamma is equal to what? 0, 0, cos pi, right, 2 pi, etc. So see, gamma is equal to 0 by 2 pi, etc. So we know the gamma you give pi by lambda d sin theta, that will give you the d sin theta is equal to what? N lambda. Okay. D sin theta is equal to n lambda. So this is the condition for interference maxima. Interference maxima. That means here we have many interference maximas. Okay, that is the condition for interference. So actually this point will be corresponds to what? Diffraction maximum also. But this also the interference here diffraction maxima. Then these are the interference maxima points. Okay, interference here also the interference intensity will be maximum. Okay, due to the diffraction. Okay, theta is equal to 0. It is equal to 0 diffraction maxima that we have shown in last class. That is simple. Theta is equal to 0, sin theta by theta is equal to 1. That is diffraction maxima. Then theta is equal to 0. That means n is equal to 0. Interference is also maximum. Okay. Now another maxima, interference maximus points are. N is equal to 1 you can have lambda by d. N is equal to 2 you can have 2 lambda by d. Okay. Then interference maxima. Now you see the d sin theta is equal to n lambda for interference maxima. Okay. Now this is an important point here for double slit. See, sin theta is equal to n lambda. Same take condition for diffraction minima is equal to m lambda. So if I take these two together, see here, maximum diffraction minimum condition b sin theta d is equal to what? This is equal to m lambda. M not equal to 0. That's you remember. M is equal to 1, 2, 3. Okay. Then similarly, interference maximum. See, interference maximum is equal to n lambda. The interference maximum, interference maximum, the diffraction minimum. Okay. Diffraction minimum. അതായത് b sin theta d is equal to m lambda എന്ന് പറയുന്നത് ഡിഫ്രാക്ഷന്റെ മിനിമത്തിന്റെ കണ്ടീഷൻ. ഓക്കെ, ഡിഫ്രാക്ഷൻ പാറ്റേണിൽ മിനിമം വരാവുന്ന പോയിന്റ്സ് തീറ്റ ഡിക്ക് കറസ്പോണ്ടിങ് പോയിന്റ്സ് m lambda by b ൽ എന്താണ് ഡിഫ്രാക്ഷൻ മിനിമം ആണ്. സെയിം ടൈം d sin theta sin theta I ഉദ്ദേശിച്ചത് ഇന്റർഫറൻസ് ആയതുകൊണ്ട് ജസ്റ്റ് ഞാൻ മനസ്സിലാവാൻ d sin theta is equal to n lambda എന്ന് പറയുന്നത് എന്താണ് ഇന്റർഫറൻസിന്റെ മാക്സിമം. സോ ഇന്റർഫറൻസിന്റെ ഇനി നിങ്ങൾ ഒരു കാര്യം ആലോചിക്കുക, എപ്പോഴെങ്കിലും ഇന്റർഫറൻസിന്റെ മാക്സിമം ആവുന്ന പോയിന്റ്, ഓക്കെ, ഇന്റർഫറൻസിന്റെ മാക്സിമം ആവുന്ന പോയിന്റ് ആയിരുന്നു ആക്ച്വലി ദാറ്റ് തീറ്റ കറസ്പോണ്ട്. ഈ തീറ്റ എന്ന് പറയുന്നത് ഏതോ ഒരു പീക്ക് കറസ്പോണ്ടിങ് ഒരു തീറ്റ കൺസിഡർ ചെയ്ത് കഴിഞ്ഞാൽ സോ ദാറ്റ് ഈസ് ദ പോയിന്റ് വേർ ദ ഇന്റർഫറൻസ് മാക്സിമം. ഓക്കെ, അതേ തീറ്റയിൽ തന്നെ ചിലപ്പോൾ എന്ത് സംഭവിക്കാം, അത് സെയിം തീറ്റ ഈ ഇക്വേഷൻ സാറ്റിസ്ഫൈ ചെയ്യുകയാണെങ്കിൽ യു ക്യാൻ ഹാവ് വാട്ട് ഡിഫ്രാക്ഷന്റെ മിനിമം. അപ്പൊ ഇന്റർഫറൻസിന്റെ മാക്സിമത്തിൽ ഡിഫ്രാക്ഷന്റെ മിനിമം വന്ന് വീഴുമ്പോൾ നമുക്ക് അവിടെ വി കനോട്ട് ഒബ്സർവ് ഓർ വി കനോട്ട് സീ വാട്ട് ഇന്റർഫറൻസ് മാക്സിമം. ആ മാക്സിമം തിയററ്റിക്കലി ഇന്റർഫറൻസിന്റെ മാക്സിമത്തിന്റെ കണ്ടീഷൻ ആണെങ്കിലും ഡ്യൂ ടു ദ എഫക്ട് ഓഫ് ഡിഫ്രാക്ഷൻ മിനിമം അറ്റ് ദ സെയിം പോയിന്റ്, അതായത് ഈ രണ്ട് ഇക്വേഷനും സാറ്റിസ്ഫൈ ചെയ്യുന്ന പോയിന്റ് ഒരുമിച്ച് സൈമൾട്ടേനിയസ് ആയിട്ട് സാറ്റിസ്ഫൈ ചെയ്യുന്ന ഏതെങ്കിലും തീറ്റ ഉണ്ടെങ്കിൽ, അതായത് ചിലപ്പോൾ m is equal to വലിയൊരു m ആയിരിക്കും, 2 or 3 സംതിങ് അല്ലെങ്കിൽ 10 or whatever, then n is equal to എന്താണ് വേറൊരു mn ആവണമെന്നില്ല. പക്ഷേ ആ കേസിൽ ഈ d sin theta is equal to m lambda, d sin theta is equal to m lambda സാറ്റിസ്ഫൈ ചെയ്യുമ്പോൾ എന്താണ് തീറ്റ d is equal to theta സെയിം പൊസിഷൻ ആണ് ഞാൻ ഉദ്ദേശിച്ചത്. അപ്പൊ ആ പൊസിഷനിൽ ഇങ്ങനെ രണ്ട് കണ്ടീഷനും സൈമൾട്ടേനിയസ് ആയിട്ട് സാറ്റിസ്ഫൈ ചെയ്യുന്നു, അതായത് ഇന്റർഫറൻസിന്റെ മാക്സിമത്തിന്റെ കണ്ടീഷനും ഡിഫ്രാക്ഷന്റെ മിനിമത്തിന്റെ കണ്ടീഷനും simultaneous at satisfy you, we will miss what? We will miss that interference maxima. That is called, that this phenomenon is called what? Missing order. Okay? A missing order of the interference. അപ്പോൾ ഇന്റർഫറൻസിന് ചില ഇന്റർഫറൻസിന് മാത്രം നമ്മൾ കാൽക്കുലേറ്റ് ചെയ്ത് കഴിഞ്ഞാൽ നമുക്ക് എല്ലാ ഇന്റർഫറൻസ് മാക്സിമം കാണാൻ പറ്റും. പക്ഷെ ചിലപ്പോൾ നമ്മൾ ഒബ്സർവ് ചെയ്യുമ്പോൾ നമുക്ക് എന്താ ആ മാക്സിമം ഇന്റർഫറൻസ് മാക്സിമം കാണേണ്ട പോയിന്റിൽ വി കനോട്ട് ഒബ്സർവ് വാട്ട് ഇന്റർഫറൻസ് മാക്സിമ. എന്തുകൊണ്ട്? ആ പോയിന്റിൽ തന്നെയായിരിക്കും ഡിഫ്രാക്ഷന്റെ മിനിമം വന്ന് വീഴുന്നത്. അപ്പോൾ രണ്ട് പോയിന്റും കൂടെ കമ്പൈൻഡ് എഫക്റ്റിൽ നമുക്ക് എന്താ വി വിൽ മിസ് ദാറ്റ് ഇന്റർഫറൻസ് order. Okay, order means first central നമുക്ക് zeroth order എന്ന് പറയും, central maximum, then first order, വെറുതെ നമ്പർ കൊടുക്കുന്നുള്ളൂ 1 2 3 4 5, അതാണ് ഫസ്റ്റ് മാക്സിമത്തിന്റെ ഫസ്റ്റ് ഓർഡർ മാക്സിമ, സെക്കൻഡ് ഓർഡർ മാക്സിമ ലൈക്ക് ദിസ്. ഓക്കെ, നിങ്ങൾക്ക് മനസ്സിലായി ദാറ്റ് ഈസ് കോൾഡ് മിസ്സിംഗ് ഓർഡർ. നമുക്ക് ടെക്സ്റ്റിൽ ഒരു പ്രോബ്ലം ഘട്ടത്തിൽ തന്നിട്ടുണ്ട്, പ്രോബ്ലം അല്ല. സോ തീറ്റ they have taken some constant value that is 0.41 degree or something. ആ ഇതിൽ തന്നെ ബിയും ഡിയും ഒരു സ്ലിറ്റ് വിഡ്ത്ത് തന്നിട്ടുണ്ട്. ആ സ്ലിറ്റ് വിഡ്ത്തിൽ നമുക്ക് ഇന്റർഫറൻസിന്റെ ഡിഫ്രാക്ഷന്റെ ഫസ്റ്റ് മിനിമം കാരണം അവിടെയുള്ള എന്താണ് ഇന്റർഫറൻസിന്റെ മാക്സിമം നമുക്ക് മിസ്സായിട്ട് കാണുന്നു. അത് നമുക്ക് പ്രോബ്ലം സെക്ഷനിൽ നമുക്ക് ഡിസ്കസ് ചെയ്യാം. Okay, that now എനിക്ക് തോന്നുന്നു you understood what is missing order എന്ന് പറഞ്ഞാൽ ഒന്നുമില്ല, ഇതിന്റെ മാക്സിമം ഒരാളുടെ മാക്സിമം മിനിമത്തിന്റെ കണ്ടീഷൻ, ഡിഫ്രാക്ഷന്റെ മിനിമത്തിന്റെ കണ്ടീഷൻ എന്ത് ചെയ്യും, ഇന്റർഫറൻസിന്റെ മാക്സിമം ആയിട്ട് എന്ത് ചെയ്യാം, കോയിൻസൈഡ് ചെയ്യുന്നതാണ്. ഓക്കെ, അപ്പം ഡബിൾ സ്ലിറ്റ് ഡിഫ്രാക്ഷനിൽ എനിക്ക് തോന്നുന്നു ഇത്രയേ ഉള്ളൂ. Now we will move on to problem section in next live class. Okay, and now we will stop here.